Hi folks. In this section, we're going to be looking at solving absolute value equations. Now, absolute values, which you may remember from middle school, basically means you kind of ignore the negative sign. The absolute value of 5 is 5, but the absolute value of negative 5 is also 5. It's a measure of how far you are from 0, and it doesn't matter whether you're greater than 0 in a positive side, or if you're less than 0 on the negative side, so long as you're 5 units away from 0 in this particular example. And so we're really using the same strategies here that we've learned in previous lessons, but this time we've got these absolute value expressions inside of the equation. So how do you solve these problems? How do you approach them? Well, the key here is the absolute value needs to be on one side of the equation. The absolute value expression needs to be on one side of the equation. And then we're going to write two linear equations that are related to each other. One of them is going to be positive and one of them is going to be negative. Let me show you what I mean. Here in this example, x minus 4 equals 6. In this example, what this means is x minus 4 could equal 6, or x minus 4 could equal negative 6. Because absolute values get rid of negative signs, we need to take both the positive answer and the negative answer into account as we're looking at this. So, how do we solve for x? In this example, 4 is being subtracted away from x, so I can add 4 to both sides of the equation. And when I do that, I get that x equals 10 is one potential solution to this equation. For my alternate equation over here on the right side, I approach it the same way. I add 4 to both sides of the equation. Negative 4 and positive 4 cancel out here, and I get that x equals negative 2. So now I have another potential solution to my equation. When you're dealing with absolute value equations, it is extremely important that you do check your answers. It is possible to come up with an extraneous solution, which is a solution that appears correct, because when you do this procedure that we've just done here, the answer looks correct, but then when you go back and plug it in later, it doesn't actually satisfy the equation. And we'll see some examples of that today. But in the meantime, let's check our answers. 10 minus 4 equals 6. Well, 10 minus 4 is 6, and the absolute value of 6 is 6, and so that is a true solution. That does work. Let's check our second potential answer here. Negative 2 minus 4 equals 6. And negative 2 minus 4 is negative 6, and the absolute value of negative 6 is in fact 6. So this answer also checks out. Both of my solutions are true solutions. Let's look at another example. 3x plus 1, the absolute value of 3x plus 1 equals negative 5. Right away, when we look at this equation, absolute values can never be negative. Absolute values are always positive. So this is an impossible equation. There is no solution to this problem because you cannot have a negative value as the answer to an absolute value expression. So this particular equation has no solution. If we look at the next problem, on the surface it looks similar. The absolute value of 3x plus 9 minus 10 equals negative 4. At first you might think, hey, absolute value equals a negative number. This has no solution. But that's not true, because we haven't gone and done our first step yet. We haven't isolated the absolute value expression on one side of the equation. So let's do that. I want just the absolute value expression on one side of the equation. I want to get rid of this subtraction by 10. So I'm going to add 10 to both sides of the equation. And when I do that, I get the absolute value of 3x plus 9 equals 6. Now I can tell, now that I have the absolute value all by itself on one side of the equation, I can tell that this is not automatically a no solution situation, because my absolute value expression equals a positive number. So, looking to solve this, I can now approach this the same way that I approached question A. I can set my absolute value expression equal to the positive 6 and set up an equivalent absolute value expression equal to negative 6. So let's do that now. Three x plus 9 equals 6, and 3x plus 9 equals negative 6. The previous question I did in 2 separate problems, but typically with these problems you do the same thing to both sides of the equation at the same time. So I'm going to go ahead and subtract 9 from both sides of the equation here and 9 from both sides of the equation here, because I'm trying to get x all by itself. 9 minus 9 is 0, so I'm left with just 3x on the left side of the equation, and 6 minus 9 is negative 3 on the right side of the equation. Now, when I divide by 3 to get x all by itself, I get that x equals negative 1. On the right side of the equation, when I do 9 minus 9, I'm left with 3x on the left side. But negative 6 minus 9 is negative 15. That means when I get x all by itself by dividing away 3, I get that x equals negative 5. So let's plug our original values back into the equation to check them out. 3 times negative 1 plus 9, and that should all be in absolute value symbols, minus 10 equals negative 4. And when you plug that in to check it out, you 3 times negative 1 is negative 3 plus 9 is 6. And 6 minus 10 is negative 4. So this value of x checks out. And we can do the same thing for the value x equals negative 5. If I plug this in for a negative 5 value here, 3 times negative 5 is negative 15, plus 9 is negative 6. Minus 10 equals negative 4. 6 minus 10 equals negative 4. And that also checks out. So my second value of x is true. Let's do another example. 4x minus 10 equals 2 times 3x plus 1. In this example, I have 2 absolute value expressions. And the strategy here is still the same so long as you've isolated one absolute value expression on one side of the equation. Then you can flip the meaning, positive or negative, of the absolute value expression on the other side of the equation. Let me show you what I mean. We're going to set this up and we're going to say 4x minus 10 equals 2 times 3x plus 1, or that's the positive version of the equation. Or we're going to do 4x minus 10 equals 2 times negative 3x plus 1. So that expression here that's in absolute value on the right side of the equation, that expression can either be positive or negative. So let's go ahead and solve the equation. The easiest way to approach this is to go ahead and do the distributive property to get rid of the parentheses there to simplify what's on the right-hand side of the equation. So 4x minus 10 equals, let's see, 2 times 3x is 6x, and 2 times 1 is 2. And now my equation is simple enough to simplify and get x all by itself on one side of the equation. So I want to get x on the right side of the equation by subtracting 4x from both sides. 4x minus 4x is just 0, so I get negative 10 equals 2x plus 2. Don't forget to have that plus 2 as well. Subtract 2 from both sides of the equation, and you get that negative 12 equals 2x. And lastly, you divide both sides by 2, and you get that x equals negative 6. So we'll go ahead and put a box around that for now. And let's see what we have next if we solve this version of the equation. Again, we have a distributive property on the right-hand side that needs to be done. I've got negative 2 times this quantity. So I need to take my negative 2 and apply it to the 3x. I need to take my negative 2 and apply it to the 1. So that leaves us with, we still have 4x minus 10 on the left side of the equation. And on the right side, negative 2 times 3x is negative 6x. And negative 2 times 1 is negative 2. Let's, we can either, we can subtract 4x from both sides of the equation. I'm going to add 6x to both sides of the equation because I like to get rid of negative numbers whenever I can. On the right side, the x's disappear, and 4x plus 6x is 10x, but we still have the minus 10, and that equals negative 2. I'm now going to add 10 to both sides of the equation so that my 10's disappear from my 10x, and I have 10x equals 8. I can now divide both sides by 10 to get x by itself, and x equals 0.8. I'm out of room here, but for right now, I'd love for you to pause the video and check to see that these are in fact both valid solutions when you plug them back into your calculator, back into the original equation, that you do, those are both valid solutions. Let's look at an example where we don't get two valid solutions. I'm going to go ahead and clear the screen here just so that we don't have quite such a mess. So let's look at an example. I keep on telling you how important it is to check your answers, and I haven't shown you an example yet where checking your answers has made a difference. So let's look at one of those examples now. Here we have the absolute value of 2x plus 12 equals 4x. So let's go ahead and plug in numbers or set up our two related equations. We already have our absolute value expression isolated on one side of the equation, and so we are able to set up our two expressions, or our two equations. 2x plus 12 equals 4x, and 2x plus 12 equals negative 4x. So let's go ahead and solve these. I can get x on one side of the equation here by just subtracting 2x from both sides. That disappears, and I get that 12 equals 2x. And if I divide both sides of the equation by 2, I get x all by itself, and I find that x is 12 divided by 2, or 6. For our other equation that equals negative 4x, I can also solve this. Let's see, I'm going to add 4x to both sides of the equation, and I get 6x plus 12 equals 0. So I want to get x by itself. So subtracting 12 from both sides of the equation gives me 6x equals negative 12. And now when I divide both sides by 6, I get that x equals negative 2 as my solution. So let's check the answers to our problems and see if it makes sense. So let's try x equals 6 first. I plug that back into my original equation. 2 times 6 plus 12. And take the absolute value of that entire expression. That equals 4x. I'm sorry, 4 times 6, because of course I'm plugging in my value for x everywhere I see it. On the right side of the equation, I have 24. And if you input this value into your calculator, 2 times 6 is 12, 12 plus 12 is 24, and you do in fact get that 24 equals 24. So this is a valid solution to the equation. Let's check our other value now. X equals negative 2. I'm going to plug that in everywhere I see x. So 2 times negative 2 plus 12 equals 4 times negative 2. I now have a situation where when I simplify what I have on the left hand side, 2 times negative 2 is negative 4, plus 12 is 8. So I have the absolute value of 8 equals negative 8. Remember, you cannot have an absolute value equal to a negative number, equal to a negative value. It is not a valid solution to the equation. So even though when we solved the problem, when we found the solution for x, it seemed like a valid solution. In reality, this is an extraneous solution, and there is no way for us to know that unless we actually go back and plug the value into the original equation and see that it doesn't work. So it's extra important to check the answers to your questions when we're doing absolute value expressions. Now, let's look at another example. X plus 5 equals x plus 11, but both of those expressions are in absolute values. So we already have one of our absolute values isolated on one side of the equation. So this is ready to set up as two related equations, one positive, one negative. So let's look at that. X plus 5 equals x plus 11. And then the other related equation is x plus 5 equals negative 1 times x plus 11. So it's like we take the whole right-hand side of the expression and multiply times negative 1. So we need to solve both of these equations now. Let's focus on the left-hand side first. We'll subtract x from both sides of the equation, like this. And when we do that, we end up with this equation, 5 equals 11. This is never true. There's no solution to be seen from this side of the equation, or this version of the equation. So let's check out the other example, the negative version of the equation now. X plus 5 equals negative 1 times x plus 11. Let's go ahead and do the distributive property here to make that easier to just simplified. X plus 5 on the left equals negative 1 times x is negative x. And negative 1 times 11 is negative 11. So now I can get x on the left side of the equation by adding x to both sides of the equation. I have 2x now on the left-hand side. And I still have a positive 5 on the left side, and I still have a negative 11 on the right side. But I can subtract 5 from both sides of the equation. So I get 2x equals negative 16. And then I divide both sides by 2, and I get that x equals -8. Now, here I had no solution. Here I had -8 as my solution, but I should go back and check to make sure that -8 actually works as a solution. So I plug it back into my original equation, -8 plus 11. And what I find is that -8 plus 5 is -3. And -8 plus 11 is +3. And the absolute value of -3 and the absolute value of +3 is in fact 3. So this is a valid solution to the equation. One thing I'd like you to notice about these problems that we've done is that you are more likely to get an extraneous solution when you have x in more than one location in your problem. So in question A, x only appeared once and both of our solutions were valid. Question B, an absolute value being equal to a negative number is just not possible. And so that is one situation where you would find no solution. But question C only had x appear one time and both of our solutions were valid. Question D, this is where we're starting to have x appear twice in the equation, although for that particular example, both answers were valid. If we look at part E, we have x appearing twice, and this is where one of our solutions turned out to not be valid. And similarly with question F, we had x appearing twice in the equation, and one of our solutions or one of our branches of reasoning turned out not to be valid. So be extra aware and alert when x appears more than once in an equation. Let's look at a real world example now and see how to approach a problem like that. So I'm on a highway 250 miles from the state border, and I set my cruise control to 60 miles per hour and want to turn it off near the border, whether I'm 30 miles this side of the border or 30 miles the other side of the border. I don't care. What is the minimum number of hours you will have the cruise control on? What is the maximum number of hours that you could have the cruise control on? So just like we've seen previously, it is important to know that speed is distance divided by time. And another way to write that same equation is time times the speed equals the distance. In this example, we know a lot about our distance. So I really want to be able to kind of use time and speed to really focus on distance, because this is all about distance from the state border. So basically, I don't care whether I'm this side of the border or the far side of the border, so long as I'm 30 miles away. It could be positive 30 or negative 30. So what I'm going to do is I'm going to set up my equation. It's going to be some sort of absolute value, because I don't care whether I'm 30 miles this side or 30 miles the other side, where my absolute value expression is going to be equal to 30. Now, the distance that I travel, I'm going to be going 60 miles per hour, and that 60 miles per hour is my speed. And if I multiply that by the time that I'm traveling, then that will give me the distance. And I want that distance to be compared to 250. If I subtract 250 from that distance that I travel, that should get me within 30 miles of the state border. So that's what I'm going to do here. I'm going to say that my speed times my time minus the 250 miles that I have to go to the state border is going to get me my value of 30 here. Now, I do know my speed. I can't solve this equation right now because I have two variables in it. So I'm going to replace speed with the speed that I know, that's 60 miles per hour, and I get 60t minus 250 equals 30. So this is my equation. I only have one variable, so it's ready to solve. And so I'll just solve it by setting up my two related equations, one of them positive, one of them negative. So 60t minus 250 equals 30. And I'll also test 60t minus 250 equals negative 30. So let's solve these both now. I'm going to get t all by itself on one side of the equation by getting rid of this number that's being subtracted from it. So I'm going to add it on. And I get as my value that 60t is equal to 280. And when I divide both sides by 60 to get the 60 away from the t here, I get that my time could be 4.7 hours. It's actually 4.66667 hours. Looking at my other equation, I have 60t minus 250 equals negative 30. So again, I'm going to add 250 to both sides of the equation. And I get that 60t equals 220. And when I divide both sides by 60, I get that time equals 3.7 hours. And again, this could be, it's actually 3.66667 hours, but it rounds off the same way. So whether I drive for 3.7 or 4.7 hours, 3.7 hours if I stop this side of the state border, and 4.7 hours if I stop the other side of the state border. That's how long I will have cruise control on according to this problem. I hope this helped.